Is there some smallest unit of length? How many moments are there in a period of time? Let's consider. Hello philosophers, I'm Chico. Welcome to the Philosopher Show, where we consider the greatest questions of human history. When I was at the Air Force Academy, people used to distinguish between fuzzy majors and non-fuzzy majors. Fuzzy majors being stuff like the humanities, and a lot of people didn't like the fuzzy majors. They're very technically minded people at the Academy, and they wanted yes or no precise answers. Math was considered a paradigm non-fuzzy major. I mean, you follow the rules, you get the right answer every single time. Here was at least one part of reality that we could be certain about. But there was always something that bugged me. Consider, for example, a circle. Now, you could draw a line from one side of the circle to another, right through the center. We call that the diameter. Pick up that line, lay it around the outside of the circle, the circumference for you mathletes, and ask yourself how many times you can do that. Crazy enough, doesn't matter how big or how small the circle is, it's always going to be 3 and some change, right? Like 3.1415, etc., etc. This is the number we call pi, and we make 5th graders memorize every digit they can in some kind of weird competition that is absolutely pointless. Not sure why. What's weird here, besides memorizing those many digits, that number doesn't ever end, right? The digits go on into infinity, which means there is no last digit to that number. If there were, we could add just one more digit to the end of that string, and that would prove that it wasn't infinite before. What bothered me about this is that sounds incomplete. I mean, it just doesn't stop going on. How can such a number exist? What's worse is, pi isn't the only number like this. There's a whole slew of these numbers called irrational numbers, and some of them are very important in math and in life. For example, Euler's number E, the golden mean, square root of 2, and it might just seem like this is some weirdness of math. So let's put this in some concrete terms so we know that this is actually a problem. In my last video, I mentioned that I used to run the 400 in high school. The 400 is one full time around the track. Let's not consider those long straight parts of the track. Let's consider just the curved parts of the track. Imagine that, and I run around the track one time. How is it that I get to the end if that end is an incomplete number? How is it that my toe crosses the finish line? Imagine you going 3 diameters and then you go 3.0001002. How do you get to 3.12, 14, blah, 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 blah? How do you get to that number if it doesn't really seem to exist? But then again, it's not really 3.0001, right? I mean, this is starting to sound like a paradox that's a lot more basic. Now let's consider those straight parts, those 100-meter straights, right? And let's just consider one of them. How do I get across that one? Well, in order to get across that 100 meters, first I have to go halfway, 50 meters, right? Before I can get there, I have to go halfway of that, 25 meters, and then halfway for there, and I can keep going like that all the way on to infinity. But wait a second, you can never get to an infinity that way. How do I even get started getting across this track? And yet I do. So this seems to be what's our problem. Every time you divide a length in half, you're left with 2 equal lengths. And these lengths are all the parts that go up to make the original length. The problem is, a length is always divisible. I mean, that's what makes it a length. So it seems like you should be able to divide this an infinite number of times. In other words, any length should have an infinite number of parts. This is a point made by Aristotle thousands of years ago in his book Physics. Infinity first shows itself in the continuous because it's constantly divisible, and a length is a continuous thing. Now you might object here, what about like an atomic length? What if the world is made, and I don't mean by that, by the way, like the length of an atom, I mean like an indivisible length. What if the world is made up of some smallest unit of length and you can't divide it any further? That's definitely a possibility, but I'm not talking about physical limitations of the universe. Here we're looking more at logical parts. Let's imagine that super small atomic length. Zoom in on that mentally, right? And ask yourself the question, is there half of that? Well, yeah, there is. And there's going to be half of that half. So on and so forth to infinity. Now let's think about these smallest infinite number of parts. What are they like? Are they of some length? Well, they couldn't have some length to them. Otherwise, you could cut them in half again. Not only that, if you have an infinite number of parts and they have some length, no matter how small they are, add them back up again and that results in an infinite length. But remember, we only have 100 meters to work with. That's strange. How can you fit an infinity within 100 meters, right? How can you make an infinite finite? I've had some students bring up the possibility of an infinitesimally small unit, right? So not some number, but not quite zero. Personally, it's hard for me to make sense of what that means, but at the very least, we could say we're talking about a distance. So if it's not zero, it's some distance from zero. And if it's some distance from zero, it's got to be some kind of length. So it seems like the length of these infinite number of parts must just be zero. And that's what a point is, right? A point is of zero length. So 100 meters is made up of an infinite number of lengthless points. If the points have no length to them, then even if we have an infinite number of them, how do we add them up to make 100 meters? Worse yet, it seems like the same problem would be with the 50 meters. It would be made up of an infinity of points, and yet it's half as big as the 100 meters. Now, the concept we're dealing with here is called infinity by division, and again, it was pointed out by Aristotle thousands of years ago. And it leads to this weird paradox. It seems like a length must be made up of an infinite number of non-lengths, but how can an infinite number of non-lengths make up a length? And it seems like any length will be made up of the same number, infinity, of parts as any other length. What's going on here? In the next video in our infinity series, I'm going to talk about something that's even more bizarre. The fact that time can be considered a length. Stay tuned for that one. But if you have any questions on this video, please hit me up in the comments. If you have any friends that really like math, they might be interested in philosophy math, please also tag them in the comments. That'd be sick because we get to start the conversation going. Please stay tuned to the playlist. I got some cool videos coming out. But that's all I got for today. Adios.